Hello, I hope you doing all well. So welcome to our today's lesson. Kindly confirm whether you can see my screen and whether I'm audible before we begin. Yes, Caroline. Hello, you can mute your mic, Caroline. Yes, am I audible to everyone? Just in case you can't see my screen, you let me know. So previously we went through the process of doing logistic regression, but we did not manage to run it simply because we did not have the dataset. I shared the dataset with you. Okay, sorry for that. So as I was saying, I shared a data set. So if you haven't downloaded it yet, you can check on your email. It is a data set known as NLSY 1997, and it's reading chapter 11. So it's NLSY 97 chapter 11. So that's the dataset I shared, so you can download it so that you're able to use it. It's a national longitudinal survey of youth dataset. Of course, it's accessible online, but now differently. So what is logistic regression? Logistic regression is a special type of regression that is used for binary outcome variables. I mentioned this, binary meaning 2 in most cases, and we said that the dependent variable, when you are indicating the regression, for example using our data set, you have a regression, you use the command regress, then you'll have the dependent variable, then anything that follows will be treated as an independent variable. So just a minute. Yes. Okay, sorry for that.
Can't hear you.
Okay, sorry, I was on a call, so I had to go about that. But I hope you can hear me now.
Yes, I can hear you now.
Okay. Thank you. So as I was saying, previously we went through the process of logistic regression, but I didn't manage to run it because I didn't had no time to maybe share the dataset, but I shared it earlier and last week, so you should be having it through the email. And I'm saying it's the NLSY97 chapter 11 data, and it's a national longitudinal data survey of the youth data that we're going to be using. On the other hand, logistic regression is a special type of regression that is used for binary outcome variable. We're having an example here when you talk about a married couple getting a divorce. So one of the best predictor here is marital stability, is the amount of positive feedback. So when you're talking about married couple getting divorced, you're going to have the positive feedback of a spouse gives her or his partner. So how we get the binary outcome out of getting divorced, using positive feedback. Of course, apart from having a positive feedback, you'll have a negative feedback. So you're having a positive feedback, negative feedback. Alternatively, you'll have an outcome whether they get divorced at the end of the day or they don't get a divorce at the end of the day, depending on the feedback generated. Other example here, we're having a woman is diagnosed with having breast cancer. We have a person to be hired. We're having a new faculty member and tenure. We have a participant in a study drops out of the program, a candidate is selected, and so these are just examples, some of the examples, but there are a lot of them out there. We have our data set. This is the data set. I just added an explanation so that we're able to understand what is contained in this data set. So is a series of questions that were asked, and it was asked about the behavior, drinking behavior among adolescents between the age of 12 and 16. Yeah, one question asked how many days, if any, each youth drank alcohol in the past month. Yeah, we have dichotomized this variable into binary code drunk 30, that is coded 1 if the youth reported having a drink in the past 1 month, and 0 if the youth reported not having had a drink in the past 1 month. What I'm trying to explain, that this will be definitely our dependent variable. If you remember, when we previously did this, we said that we start with the dependent variable, and with regression, the dependent variable will be the one which will exist as a binary outcome, because it's the one we're predicting, and as well the rest, it's not a must the dependent variable, the independent variable, all of them to be binary, but for the dependent variable in this case, it must be a binary outcome. And here we're using a drunk variable, whether a person did drink or not. If they did for the last 1 month, it's coded as 1. If they didn't, it's coded as 0. Yeah, so our contention is that the greater the percentage of your peers who drinks, the more likely you are drinking too. Yeah, that's one of the contrasts that we are having here. If you're having a greater percentage of your peers who drinks, that means you're more likely to drink too. You have, the more often you have a meal together with your family, the less likely you are to drink, because if you're having a meal, especially evening meals, then it's more likely you won't be with your peers in drinking. Then also having meals together with family is a limited indicator of parental influence, because you always are at home with them, but whenever you are out, it's possibly you could be heading to, or you could be with your peers drinking. So that's the purpose of our analysis. Note that we are working with drinking as our dependent variable, depending on what we have within our variables. So let's go to our, so my screen is visible, you can let me know just in case. So I'm under the Stata view, and today I will of course be using the commands, because it's much easier to use the command, but I'll try my best to use the menu tab to show you different ways of using the tab. For example, we can go to statistics, summarize, and table tests, and of course we want the summary and descriptive. Yes,
I can't see.
You can't see? What can't you see? The
Font
pop-ups?
size what font sizes are too small?
You can zoom it from your end. I'm not able to zoom the pop-ups. on my end, so you can use the zoom option on your end. Yeah, the only thing, if you may have noticed from the past, the only thing I'm able to zoom and increase its size is the command. So I wanted to do summary using the menu tab. You go to statistics, summarize, tables and tests. We have the summary and descriptives, and I'll choose just summary because we want to summarize. Yes, Frederick. Okay, so there's a summarize pop-up that comes, and you'll have the variable list area, so you can maybe use the drop down at the end because you'll have your list of variables indicated at this point. So let's load the dataset we're going to be using. I said we're going to be using the NLS Y 97 chapter 11 dataset. So because it is a starter file, to work with it, you go to file. Yes, Caroline.
I'm trying to connect my phone, sorry.
Okay. So you go to file, of course you click on open and then locate the dataset, or you can just use this icon here for open. It's one and the same. On the pop-up, locate the dataset I shared with you, the NLSY 97 chapter 11 data. Select on it and then click open, and you can see the command here says use, and then the path where the data is located, yeah, and the data name with its extension, and lastly we clear. The major purpose is just in case we have any other existing data set. So now that we have the dataset, we can go and use the analyze tab. I'll go to statistics, summarize. We have summaries, tables and tests. Then on the pop-up we have summaries and descriptives. Go with that. I'll choose the first option, summary statistics. And then now that we have the data, you should be having a drop down and a list of the variables to work with. Yes, George.
After opening, the data is telling me that I have no room to add more observations.
Can you try to load another data set, a different one I shared earlier on, and let me know whether it's loading? For example, the quarterly, the auto, any other previously shared starter file.
Okay, let me try and see.
Okay, you can mute your mic in the meantime. Okay, that's better. So we're having a drop down here showing the list of all the fields. Of course, you can use the edit tab or go to data and data editor so that you're able to see how the data set looks like. But in our case, we want to work with, we want to see the summary of drunk. Remember, the drunk is coded as drunk, that is coded as zeros and ones. We have age, we have the P drink here. We can check on the previous area here that the probability P drink is for the probability of drinking. I wanted to check on something. Okay, so we having P drink, we have dinner and the gender. Yeah, so So what you just need to do is select the variables. For example, we have drunk 30. This is the first variable. You can just scroll, you'll get it. Alternatively, you can try to type the name, drunk 30. Oh, let me see whether it's typing. I can't see any pop-up. If you know the name, you can type it. Alternatively, you can relook it in here. Oh, it's the last command, second last. So here it is. So let me select it automatically so that I don't have unintended option. So I have drunk 30. We said it's the coded whether someone is drinking or not drinking. Then we have age. You just use the same drop down, nothing, you're not spacing. Click on age, select the other variable is probability of drinking. You can see I'm just selecting, I'm not spacing, it spaces itself accordingly. Then we have dinner, still on the drop down. Okay, and lastly meal. Then once you create or you select the variables, you can see here we have options. We have standard display, we have addition of statistics, no display, just calculate the mean. If you just want the mean, use variables display. So you can just leave it as default and then click on OK. Remember, when you click on OK, the pop-up disappears. Alternatively, if you click on submit here, you get the results, so that if you want to adjust anything, you can be able to adjust. So you can see I clicked on submit. This is the table showing summary of drunk, age, drink, dinner and meal, and as well as the output, the summary output. This would be the same case if I ran summary or summarize drunk 30, age 27, probability of drinking 97, dinner and meal. The same thing if I type this command. And remember, summarize, we say the short form for summarize is sum, S-U-M. We can use that and list. So this is how we go about summarizing using the menu tab. You get the result. Note, when you're using, so I'll just click OK so that I close on this. When you're using the menu tab, and maybe you want to reuse a specific command over and over again, unlike if you have to copy it, you copy it from this point and paste it into the do file. You're not able to use this command. I wanted to mention something. For example, if we create a data set in Stata, the way we did by a set observation as, and then we generate variables, and so yeah. When we are working with such data that we create on the Stata, using the save tab we have here, or file, and then we have save and save as, you're able to save that data set, not the output, not the results, but the data set. Okay, so let's get into what we wanted to do. That was just summary to help us understand the distribution of the data, and as you can see from the results, then the mean here is 0.4. yeah. Then we have 14, the mean age is 14. Remember, our data was collected for the age between 12 and 16, but I can see the maximum here is 18. Then we have drinking here, probability is 2, minimum of 1 to 5. I guess this was rating. Then we have dinner, and lastly our output results. So what we're getting is just the summary, the observations, the number of maybe observation involved, and such. You may realize that the observations here are changing. The observations that were recorded for drunk, for age, for drink, for dinner, for meal, they are quite different. Apart from for male and age are quite similar. One of the reasons that could cause the difference is things such as missing values, if no response, so such cases. So on regression, back to logistic regression. So here we have our results. So maybe to give a better explanation on here, the mean of drinking is 0.451688, and this means that around 45 points of the students, because the people aged between 12 to 18 are students, 45% of the students reported drinking at least once a month. So that's according to the results that we have. On logistic regression, we have two commands when we are running the logistic regression. One, the logit. You can see that we're going to see results in a few, and then we have logistics itself. Logit command gives the regression coefficient to estimate the logit score, whereas the logistic command gives us the odd ratio we need to interpret the effect size of the predictor. So for example, how we did the normal regression, the linear logistic regression, how we interpreted the results, it's closely the same as the logistic, how we're going to interpret the logistic regression output. Yeah, so it will help us interpret. It will much be easier to interpret how much is the effect of a specific variable in predicting the dependent variable. So on Stata, if I go to statistics, we have binary outcome, we have logistic regression, the first one, that is the logit we are talking about. When we come to logistic regression, report odd ratio is what we are calling as logistic command. The command will show you. So for example, if I go to statistics, binary outcome, then click on the first one, logistic regression reporting coefficient. Choosing the variables is done one and the same. You have the dependent variable list, the independent variable. Of course, dependent variable is one, but the independent list, you can have a couple of them. In our case, we can use the drunk 30, that's our dependent variable, because we want to predict the score of someone drinking at least once a month, or a person not drinking at least once a month. And then we want to predict using things such as their age, their probability of drinking, their dinner, and also the gender here. So the dependent variable, we have a drop down here using the three dots here. You can see this is for creating a time series variable, like setting a time series, and we don't want to set any time series because we are working with normal data. So just click on the drop down here, select the second last command or the second last variable, or rather we can say field, drunk 30. The independent variable, we're going to have a couple. So we have the age as one, so you can just click on it. You're doing nothing else. Click selection age, relocate the other variable, select on it. That's how we go about it. So we have age, we have dinner, we have paid drink, and lastly you can add the male. That's all. So you can see we're having just one variable here for the dependent variable. If you select a different one, it changes. It's not like how we are adding the independent variable, because the dependent variable, if you may have noted even with the previous classes, we just need one dependent variable, then you can predict it using any other variable or any other list of variables. Once that's done, just click on OK. You're not adjusting anything else. One, I said this is the logit way, and the odd ratio one is for the logistic. So you can see the command here reads logit, the dependent variable rank 30, and the independent variable is running from age all the way to male. These are the results. Of course, we have iteration. We said it's the repetition of variables, and then we have the likelihood, log likelihood. We have the outcome of the regression, of the logistic regression. Number of observation is 1654. We have the LRK 2, which gives 72, and most importantly is what we're getting here as the probability or the chi value, the p-value, and also have the pseudo R2, also small. We're going to talk about them in a minute. We have the normal regression table. These are the variables. We have the coefficients. We have the coefficients. For age is 0.15. For dinner it's negative 0.5. P drink 0. Male as well as in the constant. Yeah. So it would be the interpretation, as I said, is one the same. For example, we can say that we can predict that this would be across age, as a person maybe as the age, or we can say increase in years of someone's age leads to 0.0.15 results increase in predicting the person drinking at least once a month. So we can say an increase in age, this in years, we can say it leads to increase in, or it leads to 0.15 increase in drinking, or probability of drinking at least once a month. So the explanation of the results is closely operative as we previously saw. So here are the results for logistics. So we can do for logit. So we did for the logit, and that's why you can see here we're having our command leading as logit. If we do the descriptive, the regression, say go to statistics, binary outcome, and then choose a regression reporting odd ratio. Yeah, remember we said the logistics, if you check on our notes, we just said that the logit command gives a regression coefficient to estimate the logit score. But when we do the logistic, it gives us the odd ratio we need to interpret the effect of the predictor. So I run the same, choose the same variables. The dependent variable will be rank 30. The independent variable, as I said, we're going to have a couple of them, beginning with gender. We have dinner, we have pay drink, and lastly the last variable here is male. Then click on OK. Remember we said if you click on submit you get the result. If you're okay with the results generated, you can just click on cancel. Yeah, so I click on submit and these are the results. If you click on OK, it regenerates the results, so no need of clicking submit and then OK. You either click submit or OK. Otherwise, if you click on one of them, you can cancel if the result is generated. So we having our logistics. So you can see what we generated using the odd ratio, using the statistics, binary outcome, logistic regression reporting odd ratios. The result is reading for logistics. According to our interpretation, the logistic command gives us the odd ratio, needs to interpret the size of the predictor. So that's what we're having, logistics, and then the variables are generated. Let me resize this so that we're able to see both results. So as you can see here, the results we have here is for logit. So we have logit analysis, and then we have down here logistic. One is for odd ratio, which is the logistic. By result, if you check on the results, you can see on variation from one variable result to another. So I hope you are able to run the analysis to this point.
Excuse me.
Yes.
Why is it my Stata is not running up? It's not opening. So it cannot find Stata directory.
Did you delete something, or did you change the Stata location from where it was?
No.
Okay, maybe you can go through the process whereby if it's not opening, it means that there's something or some changes adjusted to it. You can go to your computer and then locate under downloads your Stata and try to go through the steps how we went through before we launched. If you have
your link to receiving
okay, you don't have to you don't have to get the link. You just need the download. The download itself, it's Stata. It's just Stata. You can just search at Stata from this point. You should
go to history.
Yes.
Can I full download history?
Don't download it. You don't need to download it. Do you have your download list where you save your downloads?
Stata.
Okay.
So I open it.
You can open it. You can try to.
Then password ilikuwa
1 2 3.
1 2 3.
Yes.
So endelea tu ita download.
It's just installing, so it won't take time. So yeah, it won't.
Then I click corporate. I'm a Stata corporate.
Yeah, Stata. The folder itself. You know, sometimes you might be having the folder and a text file. So don't open a text file. Open the folder.
It's running.
Oh, okay.
Can go on. Unaweza endelea tu ina run.
Oh, ni sawa. It's okay. So as I was saying, both of the results we getting here are giving closely same result output. For example, if you check on the number of observation, the error chi4 here, it's 78.01 for both of them. The probability chi2 is 0.00 for both of them. The pseudo R2 is the same 0. Yeah. But as I said, we having logits in our logits analysis. It gives us the coefficient for estimating the logit score, what we have here, the coefficients, and then what we have under logistics is the odds ratio results. I believe you can see some differences. Here we're having coefficients. Here we're having coefficients for logit, and under logistics regression we're having odd ratio result. Yeah, it may be some analysis you may run using another command, using a different software. For example, the logit, you can see in our case we are getting iteration and log likelihood. Another alternative that maybe probably you might experience, yeah, using a different software is what we call ordinary least square. So, but we don't have here that in our case. So let's talk about the results we have here. For example, the air archive. This is the likely log likelihood. Chi is the log likelihood ratio. Log likelihood ratio. Log likelihood ratio. That's why it's reading log R. Log likelihood ratio. Chi. For chi-squared test, and the result we have seen is the same for 78.02 is the same case as what we are having here. Log likelihood ratio again is 78.01, and then we are having our p-value. We are having our p-value, so our p-value here is reading 0.00. I'm not sure how far the 0 is going, but it's 0.00. If you remember the test using SPSS, if you're having 0.00, you could manage to maybe click on it to just see the entire results, because the value is not usually 0.000. It's having some small value at the end. So you can check on that. I hope you're having the results. From the coefficients, because we say this we're using to predict the logit analysis, we have said we're having positive inference for age. Age is one of the positive predictor of drinking. We have dinner is negative. Yeah, negative. Probably we can check on how is these variables maybe adjusted to. I'll go to edit, I'll go to data editor, and then we have edit to open the dataset in an edit mode. And we can maybe go through some of our variables. And scroll to the far end. We have dinner. So if you want to see how the dataset is sorted, yeah, you can go through the variable name. This is dinner. if it has value label, you'll be able to see it from this end. So no value label, and I can see the output is the 2, we have 7, we have zeros, then we have the D itself. Where's the distribution of the variable? So the only variables that have value labels is the race, whether you're white, sometimes, and so on. Then we have the ethnicities. So the others don't have value labels. Oh, what about the gender? And the gender as well should be having value labels. Oh, it's just listed as zeros and 1, a male or a female. Yeah, then we have positive for probability of drinking, it's positive. Gender influencing is negative. So if you were to say, for example, gender, we have in 0 for male, 1 for female. When you say an increased unit, it means an increased unit in male, it means that if we move from a male to female, it means that if we move from male to female, it means we are decreasing, it leading to a unit decrease in the result for drunk or drinking once a month. So it's always good to know what the value, specifically what the values represent, so that when you talk about a unit increase, you know you're increasing from what direction, so that you don't misinterpret the results that you generate. So that would be a good way to go about it. When we come to the odd ratio table, we were interpreting on the logic. The logistic is when we talk about the odd ratio, and you can see that on our table. And we can see here, for example, age has an odd ratio of 1.169241. Another most important thing is the p-value, which is 0.008. So we can say that this is less than, just as we saw our probability here for chi here, it's less than 0.01. Sometimes we use 0.01 as I said, or 0.05, but this is smaller than 0.01, as well as the p-value for odd ratio here is less than 0.01 because 0.008. So what this means, I want to make sure you get the difference between the logistic for odd ratio and when we are working with the log likelihood of showing the effects. What the odd ratio means, where we are having for age, yeah, it means that the odds of drinking is multiplied by 1 point, you can say 1.17 to use 2 decimal places. So we have the odds of drinking is multiplied by 1.17 for each increase in age. I don't know whether you get that. Here, when we're talking about logic, we say a unit increase in age is leading to 0.01, say 0.016 increase in drinking. When we come to odd ratio, we're saying, starting with the age, the odds of drinking, because we're having the odd ratio, is multiplied by 1.17, this is in 2 decimal places, for each additional year in age for each increase in age. Each time you increase an year in age, then the odds of drinking is multiplied by 1.16 or 1.17 into decimal places. I don't know whether you're getting. Let me use an example. For example, say our odd ratio, the odd ratio of drinking is 1. Yeah, when the odd ratio is 1, or say more than 1, you can calculate it by one point 1.17. I'm using 1 decimal places, and you can subtract the 1 we are saying is the odd ratio, because when the odd ratio is 1 or more than 1, then you can have 1.17 minus 1, then you can multiply that by 100 to get the percentage. So if you subtract 1.17 minus 1, you'll end up with 0.17. Then you multiply that by 100, you'll get 17%. So you can say for each increase in 1 year, there will be 17% increase in odds of drinking. Maybe if you haven't come across the odds and ratios previously, you can do some research on that. Probably can help you understand. For Logistic analysis, it's simpler because we have used this in normal regression. But for logistics, so we're predicting using the odd ratio, you're supposed to maybe get some more knowledge on odds ratio, so that it's much easier to interpret the results. Are we having any question, or was there a challenge in running the analysis? You can type the command. You realize the command is so much easy. We are writing, for example, for the logics, for its logistic, this is the difference. The difference we said is for logistics, we are reporting coefficients. Then for logit, this is logistic for logit result. We are reporting coefficients. Then we have the logistic for reporting odd ratios. So the commands or the variables involved are the same, but now the command, this is logit, this is logistic, but the variables remains at rank 30, age 97, D 97. We have probability of drinking and the gender.
So if you use command, can it the result, can the result be the same?
Yeah, it will be the same.
So this one is another way of doing it.
Yeah, that's why I've always been saying, if you
command is active.
Yes.
Command is just on my side. Command is just showing me error. So I prefer this one, this method.
Okay, the only sometimes the menu tab is limited. Sorry. One thing you should note when you're using command, let me go to the do file, or I can use the command down here. It's one and the same. Okay, sorry. Let me increase the size here. The best thing about commands, all you need to know is the command that you want to use. One, this is our command. Whatever follows is the variables you're using. And I've always indicated the first variable you indicate here will be the dependent variable. Any other variable that follows, it's dependent. If you go to the do file, I'll increase the size. Another best thing about using do file is saving the command. You don't need to go through the steps of analyzing for you to be able to use the commands generated. But with do file, other than the command we have on the area, you realize it shows you the command. For example, you can see there's a different color for commands. I don't know how big this is, but I can resize it. I hope that's visible. You realize that the logistic, this is the command, the other are variables. The command logistics, the command logistic is in a different color. If I type, say, logistics, I hope you can see the difference. Yeah, so anytime you add an error to your command, it no longer exists as a command. Alternatively, when you are naming your variables, if you are generating a variable, make sure you use the correct spelling, because if you type, say I type drunk 3 and it's 30, where will Stata generate the drunk 3? So you'll end up with an error. So it's always good to note your variables correctly. You realize that once you're able to go through the process of analyzing using the commands, it's much easier, especially when you're working with advanced commands. Its adjustments is not limited as using the menu tab. But if it was successful using this way, you can go ahead and use it depending on the result you are looking forward to. And you realize any command you learn, you can generate the commands from this end. So back to our notes. So we have managed to run the results, the logistics, using the odd ratio and also using the coefficients for Logistic. And here the results. I included a sample of the results, and this is how the results explanation was. The result of the logit command shows the iterations Stata went through in obtaining its results. The logistic regression relies on the maximum likelihood estimation, rather than the ordinary least square. And I said previously, the most command or maybe probably different tool, you realize where you don't have maximum likelihood, it relies on ordinary least square. And then we have in the result interpretation. I don't know whether I share this note. I'll confirm and reshare if I haven't, so that you're able to access it from your end. We have talked a couple of times about hypothesis. We have talked a couple of times with hypothesis, so it's most important. It's very, very important for you to understand hypothesis and when you need it. For example, with the data or the analysis we just ran, we are having a term here indicated as k degree of freedom, and this is the number of predictors we're using. In our case, we have we have 4. Yeah, for example, if you check here, we are having likelihood ratio. It's reading chi2 and then 4. This 4 is indicating the number of variables involved. We have age, dinner, pay, drink, and meal. 4 dependent variable, 4 predictors. That's what the 4 here we have here means. Yeah, and the p-value, you should check whether it's less than 0.01. Yeah, I don't know whether you managed to use Stata. Caroline, you can let me know. Once you went through the steps, what did you get at the end?
Oh, this one. I thought that you were talking about the previous assignment. This one I managed.
Oh, okay.
It's working.
Okay. Oh, okay. So About the assignment, I'll show you maybe how to access it using, or how to go through the same, maybe using the command, and maybe you can try and let me know how to go using time series using the menu tab. Then you can give feedback. Previously I said you can use just the command predict and then indicate the variables you want to predict. Yeah. So that was on hypothesis testing. The results should vary depending on the number of variables or the number of output you choose to use as your dependencies. I'll do an example using what we have. So I'm back here. I've selected just the commands. You can see the commands area. I said if you select on a command here, it should be showing you on the command area. Say I reduce the number of dependencies, independent variables. Our independent variables are having age, we're having dinner and pay drink, and then gender. I remove on gender and run it. Just hit enter. The likelihood ratio reduces 1. The number of the number of variables involved is 3. The log likelihood ratio variable for chi, it was 78. Now we're having it as 77. Okay, the chi-square is significant, positive as indicated. When you come to the coefficients, we have a positive for age, we have positive for dinner, we have positive for pay drink. That is for logistic regression. That's the log likelihood ratio. If you can check here, we have age, we have dinner, we have pay drink. We don't have meal because we removed. You can do the same for the coefficients for logit. Coefficient for logit. So you can adjust on the variables involved. I've removed. You can add more variables by just clicking on the variable. You can type from where we're having here. You can add a different variable, and you'll be able to check on 1, the number of observations, the log likelihood ratio, chi, and the p-value, your variable involved, and of course the significance of all those variables. What is the purpose of the p-value we have here, both on our logistic and the logit, is because if a variable presents itself as not significant, it means that it's not a significant value of predicting a variable. For example, if here we had say 1.2 or 0.9, that means that variable is not significant. What it means that age is not a good predictor of drinking. So the significance as well is very, very important. You can always check on that. Yeah. Hypothesis testing based on questionnaire or based on questions involved in your analysis. The questions of your objective questions. They are very, very important. So we have seen how to go about logistic regression. Apart from logistic, previously we went through about the normal linear regression. So you have 2 regression analysis you're able to analyze: linear regression, logistic. The logistics is its identification is that you're using a binary outcome dependent variable. Yeah, a binary outcome dependent variable, which is not the case for our variables for the normal linear regression. Then we have the Poisson regression. Again, here the data is not normally distributed. Its distribution is accordingly. So Stata's Poisson fits maximum likelihood. We have seen that in the previous model, and the number of occurrences, or it counts the count of an event happening. Yeah. Okay, this is when you're calculating the Poisson manually, or if you want to get the idea behind where is the result we get for Poisson used from. So maybe I'll share this link. I'll share the link because I don't think Did I share the notes? Can someone confirm whether there is, apart from Stata lesson 3, do you have any other notes?
No.
Okay, so I'll share this so that we're able to use, because I'm not in a position to share this link through the WhatsApp I'm having here. So I'll just share the notes so that you're able to access the link. But what you need is you copy. You can see this is a link under website. You're using the use command and clear the your console, but the link is leading from our website, so you need to be connected to the internet to be able to access this data. So let me see whether I have it somewhere here, so that if yes, I'll be able to share it in a minute. In the meantime, I wanted to show you how to go through any other analysis using the command, using the menu tab. For example, time series. You go to statistics, you will see the command for time series. We have been running the ARIMA models. Here it is. Yeah. So this is the most you're going to be using. This is what we have been running. Then down here you see forecasting. Forecasting is where we are using predicting. So you can use the dataset I shared to try and forecast using the menu tab. If you're not able to use the command, you can use forecast using the menu tab. We have others such as graphics. We did the charts, different charts. If you click on a bar chart on the menu tab, other than using the command, all you need to do is choose a variable. Yeah, and you choose a variable from where we're having statistic to plot. It will use the mean. Of course, you can use a different variable if you choose to get. Then the variable list here. The variable list depends on the variable you're using. It depends on the variable you're using. So yeah, for example, if I go with gender as the variable, click on submit, I should be able to get an output and a bar chart in this case. You can see the do file. Okay, I can see the command ran, but I can't see the results. I don't know. Okay, it's generated, but it's generating for one variable. Let me try the male where we saw it's coded 1 for male and 0 for female. Okay, I just want to work for one variable, so you have to remove the current existing. You just need to choose the variable you want to plot for, and of course a variable depends on a chart depends on the variable you are going to be using. So this is what you're getting. You can size it to just have a view. Mean of male, I saw 0. I thought it's for female. I don't know why it's presenting one bar. Yeah, you can try different graphics. All the graphics we have here. Histogram would be better for a continuous variable such as age. So you choose the variable, run it, and you get a histogram. Okay, so that's using the menu tab. We also did another analysis. We did, apart from the graphics, we did regression, normal linear regression. So it's what we have as the second command here, the statistics, and we have linear. So you can use this step to generate the results for linear. So any analysis you saw us typing the command, of course I said it's much easier to run it using the menu tab, but it's more convenient and fast once you're able to understand the Stata commands, and of course you can with the commands you can adjust through the command to just have a view of a different way a chart, a result, and analysis can be viewed apart from what probably we have. Yeah, so you can always check on that as well. So I'll share this so that you're able to access the dataset. We previously have used a link access dataset, so you'll need to be connected to the internet for you to use this data. Otherwise, if you're offline, it won't run. Then we can maybe probably understand more about it. It's just a couple of steps to help us go through the Poisson analysis and explain or interpret the results accordingly. So are we having any question? Okay, so let's meet tomorrow, and as I said, we're going to be winding up the Stata lesson or the Stata class this week. So if you're having any question, you can reach out. For those who submitted their project, I'll give feedback in the course of this week, and then maybe just in case it calls for a meeting, a virtual meeting, I'll just reach out and maybe we can have one for better understanding of the results you generated, on how maybe probably you should have done it. Otherwise, that's all for today. Let's meet tomorrow at 8:30 as well, using the same link. So have a nice evening.